How to check earthing in real-world scenarios with a multimeter. Welcome to this presentation on how to check earthing in real-world scenarios using a multimeter. In this guide, we'll explore step-by-step methods to ensure your electrical earthing system is safe and reliable. Introduction. Earthing, also called grounding, is one of the most important safety measures in any electrical system. It directs excess current safely into the ground, preventing electric shocks, equipment damage, and even fire hazards. In this session, we'll learn how to verify earthing using a multimeter in practical situations. Tools required. To check earthing, you will need a few essential tools: a digital or analog multimeter, insulated test leads, and protective gloves. Additionally, you should have access to an electrical socket or an earth rod where the measurements can be taken. Safety precautions. Safety should always come first when working with electricity. Wear insulated gloves, make sure your multimeter is suitable for mains voltage, and never touch live wires directly. If you are unsure about the process, it is best to consult a licensed electrician. Step 1: Multimeter setup. Begin by setting your multimeter to AC voltage mode. Insert the black probe into the COM port, and the red probe into the V or OM port. For mains testing, ensure the measurement range is set above 250 volts AC. This setup prepares the multimeter for testing earthing connections. Step 2: Testing at a socket. Now, test earthing at a wall socket. Place the black probe into the earth pin and the red probe into the live pin. If earthing is proper, the multimeter should display the normal mains voltage, typically between 220 and 240 volts. If no voltage is detected, it may indicate a faulty or missing earthing connection. Step 3: Continuity test for earthing rod. For outdoor or industrial systems, you can test the earth rod directly. Switch your multimeter to resistance mode. Place one probe on the earth rod and the other on the neutral point. A reading close to 0 ohms means good earthing. A higher resistance indicates poor or broken connections. Real-world scenarios. Checking earthing is important in many real-world cases: household sockets, outdoor lighting, temporary power setups at construction sites, and in industries where machinery safety depends on proper grounding. Regular testing ensures safety in all these situations. Common issues detected. Some common issues that testing can reveal include loose earthing wires, corroded or broken rods, high resistance in the grounding path, or poor earthing in older electrical systems. Identifying these problems early can prevent accidents and damage. Conclusion. In conclusion, checking earthing with a multimeter is a simple yet powerful way to ensure electrical safety. A healthy grounding system protects people and equipment from harm. Remember to always follow safety precautions and seek professional assistance if needed. Thank you for following along.